This video is for Algebra Section 9.5. Our learning goal is the learner will apply knowledge of square roots and perfect squares to factor differences of squares. Our vocabulary term is how to factor differences of squares. Basically, it's a formula. So I'm going to have something squared minus something squared and basically pull that apart and say it's the first thing minus the second thing times the first thing plus the second thing. If you recognize this from Chapter 8, it is exactly backwards of, I believe it was Section 8, where we did a shortcut that said if it's something multiplied like this with a minus and a plus, you just square the first one minus the second one squared. You're basically doing that backwards. So if you got that shortcut really well in Chapter 8, this should be very easy for you. If you struggled with it, it might be another little struggle, but we'll work on that. All right. Prerequisite skills, you need to know square roots. You need to know perfect squares, like 16, 25, 36. You should know a lot of perfect squares off the top of your head. FOIL, you can use FOIL kind of on some of this. Zero product property, you'll basically use on the second page of the study guide. And solving equations, again, would be on the second page. All right, let's get into the problems and see how we do this. If I look at number 1, they have x squared minus 81. What you're looking for is this something squared minus something squared. Well, yeah, this is x squared minus 9 squared, right? So that means, according to our shortcut, that was x plus 9 times x minus 9. Because if we did FOIL, we would get x squared minus 81. Or if you remembered the shortcut and you did the first one squared minus the second one squared, you would get that. So this is my answer. All right, number 3. We have 16n squared minus 25. Well, can I take a square root of these? I could. It's 4n squared, and that's 5 squared, right? So it's something squared minus something squared. That means it's the first something minus the second, and the first something plus the second. And that's my answer. Again, if you do FOIL, you will get back to this, so that means it does work. Or if you know the shortcut, the first one squared gives you this, minus the second one squared gives you that, and it works. Number 5. We have 49x squared minus 32. Again, that's 7x squared, right? And you have to know the square roots off the top of your head. You have to learn them. But there isn't a square root for 32, is there? There is none. So that doesn't work. So if it doesn't work and you can't divide anything out of both these because 49 and 32 don't have any common factors, so it doesn't work. So that's where they told you if the polynomial cannot be factored, write prime. This is prime. I can't solve that. There isn't any squareds. There isn't anything I can take out. I can't do anything to that. Number 7. We have 225c squared minus a squared. And this is another one where you really need to know your square roots. 225 does have a square root. It's 15. 15 times 15 is 225. And if you don't know them, a good way to do some of these is on the side of your paper, write them out. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Write them all the way down. I would just keep going until you get one. If it doesn't come in there, like if I was looking for 225 and I did 14 times 14 is 189, I think. 15 times 15, if I did that, I do get 225. If I was looking for something in between there, I would know it doesn't have a perfect square. Like if I was looking for the square root of 200, it doesn't have a perfect square because 14 and 15 are right there, and it's in between there. Okay, so putting a list of those somewhere on your paper is a good habit, or a good way to solve these if you don't know them. So that is 15c squared and a squared. Make sure those parentheses are there because it is different. If you don't put the parentheses, that's not correct. Alright, so that means it's the first one minus, oops, sorry, I totally lost my minus sign. 15c minus a times 15c plus a. It's just a formula. I'm plugging in my numbers. The next one I have is negative 2 plus 2x squared. Well, negative 2 doesn't have any square roots. I can only do 2 times 1 to get 2. But could I divide a 2 out of here? You could take a 2 out. That would give me 2 times negative 1 plus x squared. I factored out a 2, right? You can do that. If they can be divided by something, take it out. Then, well, that's really x squared minus 1, right? That's something squared minus something squared, because 1 squared is 1. So I can do that as x plus 1 and x minus 1. Okay, because I just take these apart and put a plus and a minus. Number 11. And I'm going to go ahead and, well, not, never mind. We got 6 minus 54a squared. I can't take a square root of both these, but I can divide a 6 out of both of those. So I could leave that as 6 outside. And I'm going to put this in the other order while I do this. And I would get negative 9 a squared plus 1. Well, that almost works, but if there's a negative on my 9, I can't take a square root because it's negative. But if I got rid of that negative and I need a minus here, I just want to change both the signs. So I basically can take my negative out with the 6. So I can have negative 6, and that makes it a positive 9a squared, and a negative 1 because it changes all the signs inside. You can do that. That works. Because now I can take a square root of 9a squared, and I can take a square root of 1. So I have a negative 6 out there, still just floating around. And then that means I'm going to have the square root of 9 is 3, square root of a squared is a, and minus 1, and plus 1, because 1 times 1 is 1. Number 13. 4x to the third minus 100x. Well, I can take a square root of this, but not the x. It's going to be confusing, so I would look at, can I divide anything out of both those? Well, I can divide a 4 out of both of them, and an x out of both of them. So I'm going to need to do that. So I have 4 times x times, if I divided this by 4x, I would get x squared. If I divided that by 4x, I would get 25. Which now that works. It's something squared minus something squared, because that's 5 squared. So 4x times x minus 5 and x plus 5, because the 5 squared would give me 25 and x squared would give me x squared. Alright, number 15. I have 8m to the third minus 128m. Well, I don't think 128 is divisible by 8. But I'm pretty sure they're both divisible by 2 and an m. So I'm going to take a 2m out. So that would leave me with 4m squared minus 64, just 64, because the m's canceled. Alright, technically, these are both divisible by 4, aren't they? Okay, which means originally I could have divided by 8, but most of us probably didn't know that off the top of our head. If you did, you could. But I didn't know that until I divided, so now I could see, well, 64 is divisible by 4, and 4 is divisible by 4. So I could take another 4 out. So that 4 comes out here and multiplies to the 2, so I'm going to get 8m. Divide that by 4, I get m squared. Divide that by 4, I get 16. Now that's something squared minus 4 squared, right? So I'm going to do m minus 4 and m plus 4. That's it. Alright, let's clear the page. Number 17. 6x squared minus 25. Well, 25 is divisible by 5, but 6 isn't. There's nothing I can divide out of both of them. They're not both something squareds. But I can't do anything. That's prime. If you can't do anything, it's prime. Number 19. We have 169 x to the third minus x. My advice would be take an x out because they both have an x, so I can factor that out first. And I would have 169 x squared minus 1, because x divided by x is 1. These are still something squared minus something squared, because 1 squared is 1. So I can still take a square root and say that that's 13x, because 13 times 13 is 169, minus 1 times 13x plus 1. Okay, number 21. And here's where they really made it nice and confusing for you. So we've got a big long one here. First thing you want to look at, is there anything I can divide out of all of them? And in this case there is. You can divide all of these by 3 and all of them by x. So I'm going to do that. So take 3x out. If I divided this by 3x, I would be left with x to the third. If I divided this by 3x, I would get 2x squared. 3 divided by 3 would give me 1. X squared divided by x would give me x. And then 6x divided by 3x would give me 2. Alright, well, now we've got basically 4 terms in here, but none of those are, I mean, there's nothing I can take out of all of them. But if I rearrange them and use some skills from earlier in this chapter, I could take some things out of each one. So I would say I want to put my x to the third with my minus x. And I gotta put some brackets here. And then I want to do my 2x squared minus 2. Because that way, I know I can divide an x out of here, and I can divide a 2 out of there. Alright, let's try that. So, take out my x. That would leave me with x squared minus 1. Over here, I'm going to take out my 2, and that leaves me with x squared minus 1. That happened exactly like it did earlier in this chapter. Shocking. Alright, well that means I know that I can rewrite it as x plus 2, so taking this and that, times x squared minus 1. Alright, well I can't do anything here, can't do anything there, but that's a squared minus a squared. I can do another simplification. So I'm going to rewrite these because nothing's happening with those. But here, if it's something squared minus something squared, I can do the plus 1 and x minus 1. All of that is my answer. Those are the most complicated types of problems you'll have. Okay, so if you can get that, you can do any of these problems. Alright, and that is just the first page of 9.5. So let's go on to the next page. On the next page, it's basically the same idea, but again, they put them equal to something now. So now it's an equal sign. So I have an equation instead of an expression. And again, I'm going to want to get it so that I have 0. Because I can't factor anything with stuff on both sides. So I need to subtract 49 from both sides. So then I have 81x squared minus 49 equals 0. And you do generally want to get the squared term to be positive and the other one to be whatever the other one needs to be. Alright, so I've got that. Well, that's something squared minus something squared. So I could just take square root of both of those. And one with a minus, one with a plus. Which means now that I have it factored and I know it has to equal to 0, I can do my two equations again. Either 9x plus 7 equals 0, or 9x minus 7 equals 0. So here I'm going to have to subtract 7, because I need to take care of my adding and subtracting first when I'm solving. Divide by 9. You do get a fraction, that's okay. That's the answer. Over here, add 7. 9x equals 7. Divide by 9. X is 7 over 9. So it's either positive or negative 7/9. Alright, and a lot of times that will happen where you get a positive or a negative. Sometimes it won't, so don't assume that's going to happen every time. Number 3, we have 25d squared minus 100 equals 0. Again, this one's set up for me that it's something squared minus something squared. So I'm going to take the square root, get 5d, and plus 10, and 5d minus 10. So either 5d plus 10 equals 0, or 5d minus 10 equals 0. I'm going to subtract 10 here. 5d equals negative 10, divide by 5, and d equals negative 2. Alright, do the same thing over here, add 10. 5d equals 10, divide by 5, and d equals positive 2. So it's either negative 2 or positive 2. Alright, next page, or sorry, clear the page. Number 5, we have 36 equals 1 over 25x squared. Oh jeez, you guys hate fractions, but it's not that bad. What I would say, I want to subtract 36 so that it's all on one side. So I'm going to have 0 equals 1 over 25 x squared minus 36. Well, it doesn't really matter that it's a fraction, because this is something squared, that's something squared, that's something squared, that's something squared. So if it's squared minus squared, I can separate that and take the square root. So what would the square root of 1 over 25 be? Well, 1 over 5, because square root of 1 and square root of 25 is 1 over 5. Square root of x squared, it's x. And I'm going to have to minus and plus the square root of that. Square root of 36 is 6, so minus 6, or 1/5 x plus 6. So just because I had a fraction, it wasn't much harder. 1 over 5 minus 6, oops, sorry, x minus 6 equals 0. Or 1 over 5x plus 6 equals 0. Add 6. 1 over 5x equals 6. Multiply by 5 to get x by itself. So x is 30. Over here I would subtract 6. Multiply by 5. X equals negative 30. So it's either 30 or negative 30. Alright, that wasn't so bad. Number 7. We have 9x to the third equals 25x. Again, I need everything on one side. This is the highest power, so I'm going to move the other one. Minus 25x, minus 25x. Those cancel. I get 9x to the third minus 25x equals 0. Well, I see a squared, but there's an x in both of them I need to get rid of first. So if there's an x in both of them, I can't divide them both by anything, but I can take an x out. So take the x, and that would leave you 9x squared minus 25. Now you should see this is something squared minus something squared. So take the square roots, I get 3x minus 5 and 3x plus 5. Now I have 3 things that could equal 0. The first one's real basic, either x is 0, or 3x minus 5 is 0, or 3x plus 5 is 0. Because if all 3 are multiplied together and you get 0, one of them has to be 0. That one's already solved. Over here I'm going to add 5. 3x equals 5 divided by 3. X equals 5 over 3. Over here I'm going to subtract 5. 3x equals negative 5 divided by 3. X equals negative 5 over 3. And in this case, I did end up with 3 answers, and all 3 of those are your answers. There are times when there's more than 2. Okay, so you could have multiple answers. Moving on. Number 9. 2m to the third power equals 32m. Again, I want everything on one side, so I'm going to move the smaller power over. So subtract 32m, because that'll give me my 0. So 2m to the third minus 32m equals 0. Well, I should be able to look at this and say, well, I could take a 2 out of both those, and I could take an m out of both those, so I'm going to need to do that. If I divide that by 2m, I get m squared minus 16. That's something squared minus something squared. So, take the square root, and minus and plus. So again, I have three things that could equal 0 this time. Either 2m equals 0, or m minus 4 equals 0, or m plus 4 equals 0. Divide that by 2 to get m by itself. Oops. M equals 0. Add 4 to get m by itself here. M's 4. Subtract 4 to get m by itself there. So I got 3 answers. All of those are my possible answers. Number 11. 1 over 64x squared equals 49. Again, I need to move this 49 to the other side by minusing 49 from both sides. So 1 over 64x squared minus 49 equals 0. And you need to know those perfect squares. These are squared minus squared. And 1 over 64, the square root is 1 over 8. So I'm going to have 1 over 8x minus the square root of 49 is 7. And 1 over 8x plus 7 equals 0. So either one of those could be my 0. So rewrite that. Add 7. 1/8 x equals 7 times by 8 to get x alone. X is 56. Over here, subtract 7. Multiply by 8. X is negative 56. So there's my two answers. Alright, clear the page. Two problems left. Number 13. We have 3b cubed minus 27b equals 0. Again, you need to know your information for this, but you should be able to look at them and tell they're both divisible by 3 and b. So I'm going to divide by 3b, and that will give me b squared minus 9, which is something squared minus something squared. So I can rewrite that by taking the square root and doing a minus and a plus. So again, either 3b is 0, or b minus 3 is 0, or b plus 3 is 0. If I divide by 3 to get to get b by itself, b is 0. Add 3 to get to get b by itself, b is 3. Subtract 3 to get b by itself. All three of those are possible answers. Number 15. We have 48n to the third equals 147n. Well, again, I want to move this to the other side, so minus 147n on both sides to keep it equal. 48n to the third minus 147n equals 0. I have no idea if 147 is divisible by 48 or not. My guess would be no, but I would think I want to try it at least. So if I try to divide that by 48, it should go in like 3 times. That's 24. It's not going to come out even, so okay, I don't have to worry about that. But I would guess something can go in because n can go into them. So what else do I know 48 is divisible by? You should know 48 is divisible by 6. Oh, sorry, didn't mean to erase that. It's divisible by 6. So maybe 147 is divisible by 6. So we'll go twice. That's not going to come out even. Alright, well maybe 8. 48 is divisible by 8. So let's try 147 divided by 8. That's 167. That's not going to go in evenly either. Let's go a little simpler. What about 3? I know 48 is divisible by 3. You should know if 147 is divisible by 3 or not, because you should know your divisibility rules. If you don't, you can test it. 3 into 14 is 2. Oops, sorry, not 2. 3 into 14 should be 4. That's 12. 3 into 27 is 9. Alright, well 49, that would work. So I could divide that by 3, and you should know 3 times 16 is 48. So I could take out a 3 and an n. So I get 16n squared minus 49, which is very convenient that it's something squared minus something squared, which means square root minus the square root and plus the square root. So 3n equals 0, or 4n minus 7 equals 0, or 4n plus 7 equals 0. All three of those work. Divide by 3 to get n by itself. N is 0. Add 7. 4n is 7. Divide by 4. N is 7 over 4. Over here, subtract 7. 4n is negative 7. Divide by 4. N is negative 7 over 4. So again, all three of these are my answers. And that is the end of section 9.5.